Good evening, sir.
Am I audible to everyone?
Yes, sir.
So today we have to start a new chapter, that is chapter number 3, which is subtopic of part mechanics. Mechanics is the oldest branch of physics in which mainly deal with just two different terms. So you can say study of body at rest or in motion is called mechanics. First is rest and second is motion. Study of rest is also called statics, and study of motion is also termed as dynamics. So you can say statics is nothing but study of an object which is at rest or in equilibrium due to interaction of a number of forces. So it is termed as statics. And next is study of moving body is called dynamics. We may further divide this particular part into two terms. First, whether you are considering consequences or result of that particular motion, or you are considering causes of that particular motion. Suppose you have a body having mass m and you have applied some force to it. On application of this force, it will move along this path and covering distance, displacement, speed, velocity, and so on. So these terms are nothing but consequences or result of particular motion. But this term, force, momentum, work, energy, on application to this particular body causes this body to move along this particular path. So these terms are termed as causes of that particular motion. So you will learn in these consequences about distance, displacement, speed, velocity, acceleration, and so on. Cause of motion, force, momentum, work, energy, and so on. So this consequences of motion or consequences or result of that particular motion is termed as kinematics, and this particular cause of motion is termed as dynamics. So your whole 11th, third and fourth chapter mainly deals with this part, and the all other chapter mainly deal with just proper dynamics. Is it clear to you all till this part?
Yes, sir.
I'll just explain you about the brief idea of this whole topic. Just write it down. Do you have any doubt? Have you all written this whole?
Sir, 2 minutes.
Your voice keeps lagging.
Okay, just a minute. Hello? Is it clear now?
Yes,
No,
sir.
sir.
Have you all done?
1 minute, sir. Done, sir.
Kinematics, defined from a Latin word, kinema. We read it out as, which defines nothing but about motion. So you may say kinematics is a branch of physics which deals with impact or result of that particular motion without considering its causes. So you can say study of result of motion without considering its cause is called kinematics. Now, we may further divide this kinematics into two parts. First, uniform motion, and second, non-uniform motion. Uniform motion means if a body covers equal distances in equal time gap, then acceleration would be zero. So it is called uniform motion. We mainly define in this part about distance, displacement, speed, velocity, only these four topics. Non-uniform motion, if a body covers unequal distances in equal time gap, then acceleration would not be equals to zero. So we may further divide this particular term into two parts. First, uniformly accelerated motion, or you can say if acceleration would have some constant numerical value. Next, non-uniformly accelerated motion. It means acceleration, velocity, displacement, all these terms would have some time-dependent, position-dependent function, or you would say acceleration would be, yes,
duration.
able to understand you. Yes, Mohammed Umar?
A is acceleration.
Yeah, A is acceleration. So if acceleration is constant, so it will be termed as uniformly accelerated motion. If acceleration is variable, it will term as non-uniformly accelerated motion. We may further divide this particular uniformly accelerated into two parts, whether the motion is along horizontal path or whether it would be along vertical path. Vertical motion is termed as free fall or motion by gravity. So from this whole, we mainly have four different sections. First, uniform motion. Second, uniformly accelerated motion along horizontal path. Third, uniformly accelerated motion along vertical path. And fourth, non-uniformly accelerated motion. Is it clear to you all till this part?
Yes, sir.
Okay, just write it down.
So could you repeat the fourth point?
Non-uniformly accelerated motion in which acceleration, displacement, velocity, all these terms would have some function of dependent or position dependent as well. So we can say these physical quantities are variable. It will be termed as non-uniformly accelerated motion. Muhammad Umar?
So could you repeat the non-uniform motion part again in brief?
First, write it down. I will explain each section individually. Okay. Have you all done till this whole part?
Sir, last 2 points. Done, sir.
Now, in this whole part, I'm defining the first, which is uniform motion. Let's say if a body covers equal distances in equal time gap, then termed as uniform motion. Body covers equal distance, equal time gap. Now, in this part, the first term is, what do you mean by distance and displacement? I think you all are familiar from the early class about these two terms. Reha, would you like to explain these two different terms? What do you mean by distance and displacement? Nida?
The distance from initial point and the final point is displacement.
Okay, and what about distance? Nida?
The distance is the total path covered and displacement is the shortest path.
Okay, let's say if you have insect and you are allowed to crawl on this particular surface, so the motion would be like this. Let's say initial point to be A and final point to be B. So on going from A to B, the actual path traveled by any object for its entire journey is termed as distance. So we'll say actual path covered by body is called distance, and the shortest in between initial and final from this point to this point is called displacement. So you'll say shortest path between initial and final point of the journey is called displacement. Now, in this part, for calculating actual path length, body is going along this direction initially. Now turn along this direction, turn further, and then further, and then further. So in this actual path, the direction of body is not fixed. So you can say there is no fixed direction. But for this displacement, there is only one direction, and there would be shortest path between initial and final point. So you would say it would have fixed direction to define short. So it will be measured, and it will be also measured in terms of meter. Is it clear to you all till this part? Abhinav,
Yes,
is
sir.
it clear?
Yes, sir.
Now I'm defining you a relation between distance and displacement. Relation between distance and displacement. Suppose for a straight path first, for a straight path, the actual path length and the shortest path length between initial and final point both would be equal. So you would say distance as well as displacement both are equal for a straight path. For any curved path, let's say I'm taking any semicircular region. like this. So the actual path on moving from one point to another would be half perimeter of this circular part. So you'll say distance would be equals to just by r. For displacement, if you calculate the shortest path, it would be along diametrical line from this point to this point. So this would be your radius and this would be your radius. So you'll get just 2r. Pi is nothing but 3.14, which is greater than 2. So you would say distance is greater than displacement. So from this, you would conclude only for a straight path, distance would be equals to displacement. And for the rest of the all path, distance would be always greater than displacement. So if you relate these two terms, distance and displacement, it would be either greater than or just equal to displacement. Now, if you take ratio of these two terms, you will get distance divided by displacement would be greater than equal to just. Is it clear?
So could you explain the ratio? Why?
This particular displacement to the other side, here we would have 1 in multiplication of it. Moving to the other side, since it is a numerator, on moving to the other side, it moves to the denominator. So you get just 1 here. So it will be distance divided by displacement, which is greater than or equal to 1. Okay? So do you have any doubt to any one of you till this part? Riba?
No, sir.
Muhammad Umar? Any doubt? Have you all done till this part? Rishan? Have we done?
Done, sir.
Now I'm giving you one problem to calculate distance and displacement. A man goes 8 meters along east, then 4 meters towards north, then 2 meters towards west, and then last 1 meter towards south. Find distance and displacement from origin.
Sir, what did you write after displacement from?
Origin, starting point. Give you some clue about it, how to approach this. In this whole part, you have to define direction east, west, north, south. So first of all, draw east, west, north, south. In the first part, man is going 8 meters along east. So it will be like this. From this point to this point. Then turn towards north and move 4 meters along. And move towards west, so it will be along this direction. And last is going towards south, 1. Now for displacement, you have to define short path between initial point and final point. So from this point to this point, just draw these or join these 2 points like. Now, if you have to define this particular length,
Answer correct.
so
I've sent it in the chat box.
just 1 minute. So draw a perpendicular from this, and you'll get about distance and displacement from this part. Try to solve, everyone. Yusuf, just check your calculation. Now try to simplify it and you'll get distance and displacement both. Is it clear to you all? How I calculated this 6 meter and 3 meter? Good, Nida. Try to find displacement and it will be nothing but shortest path from O to D. Try to find hypotenuse of this triangle using base and perpendicular. Just send your answer. Rehab, Abhinav, should I solve? Let's see first. If you have to calculate distance, which is nothing but actual path length covered by the body. So just add all these terms, you'll get distance. And for the displacement, it will be shortest path to the initial point to final point. So you have to solve for this path OD. So just see in this triangle, we have base, perpendicular, and you have to find hypotenuse to get displacement. Use Pythagoras theorem to get this value OD. Nida, just check your calculation. Mohammed Umar, just check your calculation. Mohammed Umar, try again. How to calculate this OD using this particular triangle? Riba, would you like to answer? How will you calculate OD of this particular triangle? Mohammed Umar, just check your calculation. Abhinav, have you solved?
Doing, sir.
So how would you calculate this OD using this particular triangle?
By Pythagoras theorem.
Good. So we have base as 6 and perpendicular as 3. So using Pythagoras theorem, you will calculate OD. So it will be equals to root of base square, that is 6, perpendicular square, that is 3. So it will be 36 plus 9 root under, and it will be 45 root under, or if further simplified, you will get 3 root 5 meter. Is it clear? Riba, is it clear? Rehab, is it clear? And
Yes.
similarly, distance is nothing but total path length. So it will be 8 plus 4 plus 2 plus 1 and pictures 15. Mohammed Umar, is it clear?
Yes, sir.
Have you all written to this part?
Yes, sir.
The next term in this part is to define about speed. Speed is nothing but rate at which a body covers particular distance. So it will be defined as the rate at which distance is being covered by a body. So it will be equals to distance divided by time taken. I'm defining one more relation in between these three terms. Suppose if you have D, S, and T. So just cover up any of the term, you will get relation between other two. Suppose if you have to calculate speed, it will be equals to distance over time. If you have to calculate distance, just cover this, you will get speed into time. And similarly, if you have to calculate time, just cover this, you will get distance divided by speed. Is it clear to you all? Abhinav?
Yes, sir.
Okay. Now, the next term is to define its unit. Its SI unit is meter per second. But there would be problem in terms of kilometer per hour. So if you multiply it by 5 by 18, you will get in terms of meter per second. Similarly, if you multiply meter per second by 18 by 5, you will get kilometer per hour. Now, the next term in this part, which is most important to define average speed. Let's say if you have a journey which consists of a number of intervals from this point to this point. From A, B, C, and D. Distance traveled A to B is x1, x, x3, and so on. Similarly, time taken T1, T2, and T3. The speed of object corresponding to these two terms would be V1, V2, and V3. I've just assumed this particular term for each of path length. So average speed is nothing but the ratio of total distance traveled by the body to the total time elapsed by the body or taken by the body. So you would say the ratio of total distance covered to total time taken. So average speed is equals to distance covered by total time taken. Is it clear to you all till this part?
Yes.
Just write it down till this part. I'm defining some of the property for different interval to get different formula of this average speed. Just write it down till this part. Have you all written till this part?
1 minute.
Okay. You're done? Ishan?
Done.
Average speed is equals to total distance traveled, that is x1 plus x2 plus so on to xn, whole divided by t1 plus t2 plus so on to tn. I'm defining you some of property. First, if time interval for each consecutive path is same, so let's say for equal time gap, it means t1 is equals to t2 and is equals to tn. Let's say it will be t. So distance is equals to speed into time. Similarly, x2 is equals to v2 into t and so on to vn is equals to, or distance nth is equals to vn into t. Now put this all values in this equation, you will get average speed is equals to x1, which is v1 into t, x2, which is v2 into t, so on to vn into t, whole divided by time gap t1, t2, and so on to t. Now take out t as common from each part, you will get v1 plus v2 and so on to vn, whole divided by t to n times, it will be just nt. Now this t and this t would cancel out, so you will get sum of all individual velocities divided by number of interval. It is nothing but average of all individual speed. So you can say if time gap for each consecutive interval is same, mean of all individual speed. Is it clear to you all till this part?
Yes, sir.
Yes.
Riba, is it clear? Nida?
Yes, sir.
Similarly, I'm defining you for one more term. Suppose for equal path length, let's say x1 is equals to x2 and so on to is equals to xn. This whole term would be nothing but x. So time is equals to distance by speed. Time is equals to distance by speed and so on to time is equals to distance by speed. Now put all these values in this first equation, you will get average speed is equals to distance, that is x1, x2, and so on to xn, divided by time t1, which is nothing but distance over speed, and so on to x divided by v. Now this whole numerator is up to n times, so it will be n times of x. And if you take out x as common, so it will be 1 over v1, 1 over v2, and so on to 1 over vn. This x and this x would cancel out, so you will get n divided by 1 over v1, 1 over v2, and so on to 1 over vn as required term. It is nothing but harmonic mean of all individual speed. So you would say harmonic mean of all individual speed. So I'm defining to calculate average speed in three different ways. If there is no relation between distance and time, just use first formula. If time gap for each consecutive interval is same, so average speed is equals to this term. And if distance interval for that particular journey is equal, use this formula. Is it clear to you all?
Yes, sir.
Yes, sir.
Okay, just write it down. I'm giving you some problem regarding this. Speed in individual part, V1, V2, V3 are the speed in each interval gap. Have you all written till this part?
No, sir, I'm not.
Done? Yusuf, have we done?
Sir, last part.
Have we done? Do you have any doubt?
No doubt, sir.
Yusuf, have you done?
Yes, sir.
I'm giving you one problem. A man goes to market at 6 meters per second and return back to home at 3 meters per second along same path. So find average speed through the journey. So for any other problem, try to define which of the following condition would be valid in this part. I'm giving you some clue. Let's say home to market. So on going along this path, his speed initially was 6 meters per second. On returning back, it will become 3 meters per second. So what you conclude about this particular interval, whether it will have equal time gap, equal path length, or they are not equal. They have
They have same time gap.
time or distance.
Sorry, distance.
Yeah. So in this particular term, x1 is equals to x2 means equal path length. So apply third formula, but in this part we have only two terms. So just use n is equals to 2, v1 is equals to 6, and v2 is equals to 3. And just try to solve it. Is it clear to you all?
Yes.
Try to solve. N is number of interval. So I have defined you. I'm going from home to market and returning back. There will be two intervals. That's why I have written n is equals to 2. Umar. Nida, have you solved? Muhammad Umar just say, on going from home to market and on returning back along same path, whether the distance on going from home to market and market to home would change or it would be remain same. Muhammad Umar,
Understood.
that's why I have written x1 is equals to x2. It means path length will be equal. So apply third concept. So it will be equals to n divided by 1 over v1, 1 over v2, and so on to 1 over vn. But in this question, we have only two intervals. So n is equals to 2, 1 over v1, which is 6, and 1 over v2, which is 3. So if you take LCM of these two terms and you simplify it, you will get 2 divided by LCM of 3 and 6 would be 6. So it would be 1 plus 2, which would be 3 divided by 6. So it would be 1 upon 2. 2 will move to numerator. So you will get 4 meter per second. Is it clear to you all? Rehan,
Yes,
is it clear? Try to solve this question. In this question, I have given you equal time. Muhammad Umar, it is given as equal time. So use the second formula, and we have only two intervals. This is V1 and this is V2, and number of interval is only 2. Try to find. Which formula you have used? first, second, third, second. Because average speed is equals to v1 plus v2 upon number of interval, that is 2. What do you have for v1 and v2?
I have used the first formula.
Why? Why, Muhammad Umar?
Because the time is same and given.
So this is your first formula, this is your second formula, and this is your third formula.
I use the second formula. I use the second formula.
Okay, okay. Good, Yusuf. Good, Umar. Abhinav, have you solved? Nida, just send me your answer. Good, Nida. Good, Mohammed Umar. Now, if you put the value of v1 to be 12, divide by 2, 12 plus 6 would be 18 over 2, which is equals to nothing but 9 meter per second. Was it so difficult? Abhinav? This is how we calculate average speed depending upon different problem. Now, the next term is to define velocity. As speed depends upon distance, so velocity depends upon displacement. So you can say the rate of change of displacement is called velocity. So velocity is equals to displacement over time taken. As displacement is a vector quantity, so velocity must be vector quantity. And next, I have defined for a straight path, distance and displacement are equal. So you would say speed and velocity for straight path must be equal. Is it clear to you all till this part?
Yes.
I'm defining you one problem. A body is going along circular path. Let's say from this point to this point, from A to B. Find velocity if time taken is 2 seconds and radius is 40 centimeter. I'm giving you some hint how to calculate. For velocity, the first term you have to calculate is displacement. And displacement is nothing but shortest path between initial and final point. So just join these two lines. This is your radius, this is your radius, and they are inclined and perpendicular to each other. So AB would be hypotenuse of this particular triangle. So using Pythagoras theorem, you will get base square perpendicular square is equals to hypotenuse square, or it would be under root of 2, or it would be simply under root 2 times r. So this will be your displacement. And we have time and the value of radius. Put all these values in this equation, you will get value for velocity. Try to solve, everyone. Yusuf, have you solved? A winner?
So 1 minute.
You will just check your calculation. You have to convert this radius, which is in centimeter, into meter. Just divide it by 100, it will be converted into meter, and apply the formula. So from this, displacement would be equals to root 2 times of r. R is nothing but 40 centimeter. Divide by 100, you will get 0, 0 cancel out, or 0.4, or you may write it as 2 by 4. So it will be 2 divided by 5 in terms of meter. So velocity is equals to displacement, that is 2 root 2 divided by 5, and time taken, that is 2. And 2 would cancel out, so you will get root of 2 divided by 5 meter per second. I think Inda, you got this answer, but my mistake, you have sent me some other answer. Muhammad Umar, here we have radius in terms of centimeter. So first of all, you have to convert it into meter. And I have just explained you how to calculate displacement. This 0 and this 0 would cancel out. If you divide it by 2, so it will become 2 root 2 divided by 5. Okay, Muhammad Umar?
Sir, can I use 0.4?
1/4?
Can I use 0.4?
Yes, Muhammad Umar? एक बार में सबको ऊपर भेज दिए तो एक बार में रहने दीजिए सबको नीचे क्या नहीं तो अतिया जल्दी 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 दो बाद में वाली स्टार्ट कर लेंगे Okay. So do you have any doubt till this part to anyone of you?
No, sir.
Now the next part in this portion is to define. Yes, Muhammad Umar, you can use 0.4 instead of 4 by 10 or instead of 2 by 5. So do you have any doubt till this part to any one of you in this uniform motion? Now the next part is to define uniform derivative in which acceleration would be some constant or some constant numerical value. So to define this, you have to use equation of motion. I think you might have learned in class 9. V is equals to U plus A times T. S is equals to UT plus half AT squared. And V square is equals to U squared plus 2AS. And there is one more equation, that is SN is equals to U plus A over 2 times 2n minus 1. And hold this equation, you have to use first this acceleration, or you have to find this acceleration first, and then according to different problems, you have to use these equations. I'm defining you some of concept how to use this from. This whole equation, U is defining U initial velocity. Means velocity of object at initial, or let t is equals to 0. So you say velocity of body at t is equals to 0. V is nothing but final velocity. Velocity at any particular time interval. S is displacement covered by the body during that particular time. Now, according to this, I'm defining how to use these equations. First, V is velocity, U is also velocity, and T is time. Acceleration will be constant for the entire journey. So you will say first equation as velocity time relation. Second term, U is initial velocity. In most of the problem, it will be 0. So you're left with just S, which is displacement, and T is time. So you can say it would be displacement time relation. Third, V is velocity, U is velocity, and S is displacement. So you would say velocity displacement relation. And this last term is defining nothing but displacement traveled or covered by body in nth second. So what do you mean by this particular nth second, and how to use this equation and this equation and defining it? Let's say if you have,
Sir,
yes,
sir, I didn't understand. Could you repeat?
this entire part?
Yes.
Okay, good. Uniformly accelerated motion means if a body is covering unequal distances in equal time gap. But in that particular motion, acceleration of body to be constant, it means it would have some numerical value. Means 2 meters per second square, 5 meters per second square, some numerical value. Okay. So on the basis of this, you have to define equation of motion, or you can say for uniformly accelerated motion, we use equation of motion to solve different problems. as acceleration is constant for the entire path. So we have mainly 4 different equations. In 9th class, you must have learned about just 3. Is it clear, Mohammed Umar?
Yes.
Now, what these different equations would mean and how do you use in different problems? So I'm defining you. In first equation, V is final velocity, U is velocity initial. T is time, acceleration will be constant. So we can say first equation as velocity time relation. So wherever you have to calculate velocity or time, so just use first equation of motion. Similarly, in second equation of motion, S is displacement, T is time. Here, U is initial velocity. In most of the cases, initial velocity would be 0. So I have to neglect this. So you will left with S and T on. So you will say it would be displacement time relation. Similarly, third part, we have V final velocity, U initial velocity, and S is displacement. So you can say it would be velocity displacement relation. These all 3 different equations would be applicable to define relation from starting of the journey till the end point. So it will define you applied from starting to end. But this last equation would define for some other path. I'm defining you. Let's say if you have path from this point to this point, starting from 0 seconds, so it will be 1, 2, 3, and so on. Let's say this is your n second, and 1 second before it would be n minus 1 second, and it would have n intervals. Is it clear, Mohammed Amir, till this part?
Yes.
Okay. So if you have to use the above 3 equation, it will be defined from the starting of the journey till that particular point. Suppose for velocity, if you have to calculate final velocity at 3 seconds, you must need velocity at initial point, means velocity at t is equals to 0. It means it is valid from starting of the journey till that particular 3 seconds. But if you have to use this last equation, which is defining you displacement traveled by the body in nth second, it means if it would be from 0 to 1, we call it as first second. If it is between 1 to 2, we can call it as second. If it is between 2 to 3, so we can call it as third, and so on. So this particular term is defining you between 2 consecutive intervals, or it will be defining you between consecutive seconds. So this is nothing but displacement for consecutive second. So we can call it as SNF, or distance traveled by the body in nth second. So it is defining you distance traveled in consecutive time gap. Is it clear to you all till this part? Or do you have any problem? Do you have any doubt till this part? Yusuf?
Sir, do you mind explaining it again?
Which part?
Sir, for that S by T relation.
Okay, okay. The second equation.
Yes, sir.
First of all, write it down. I'm defining you. Abhinav, do you have any doubt? Are you all done till this part?
1 minute.
Okay.
Done.
I'm defining you. How to use this particular second equation? This is nothing but distance traveled by the body from starting of the journey, that is t is equals to 0 second, to that particular time interval. Because if you have to use for 3 seconds, it means from the starting of the journey, that is from 0 second to this particular 3 seconds. So it will define you distance traveled from starting till that point. Is it clear, Yusuf?
Yes, sir. Clear. Thank you, sir.
Okay. Now I'm giving you some problem regarding this. Before that, I'm giving you some assumptions. First is, if a body is starting from rest, take initial velocity u to be 0. It finally stops. So take v is equals to 0. And if body is going uniformly, we'll say uniform motion, it means acceleration would be 0 or v would be equals to u. Depending upon these assumptions, you have to apply for different problem. Suppose a body starting from rest accelerates uniformly. And covers 8 meters in 4 seconds. So find first acceleration of object, second velocity in 5 seconds. Try to solve. Do you have any doubt in this problem to any one of you? How to solve this? Should I give you some clue? Abhinav?
No, sir.
Okay. In this part, body is starting from rest. So take U to be 0. Covers 8 meters, that is distance, in 4 seconds, that is time. So using second equation of motion, try to find acceleration. Try to solve. Nida, have you solved? Just use second equation of motion, put all these values, and you will get the value of acceleration. Good, Nida. Use first equation of motion, you will get value for final velocity. Mohammed Amir, just check your calculation. If you apply second equation of motion, S is equals to ut plus half at square. Then S is 8, u is 0. So this entire term would become 0. So you're left with half. A is acceleration, which we have to calculate, and t is time taken, which is just 4 seconds. So square of it. Now on solving, you will get a over 2. Square of 4 would be just 16. So 2 in 8 times becomes 16, which is equals to 8. So you will get A is equals to 8 divided by 8, which is just 1 meter per second square. Is it clear, Mohammed Amir?
Yes, sir.
Now apply this value in first equation of motion and try to get final velocity at t is equals to 5 seconds. Riyadh, do you have any doubt till this part?
No, sir.
Here your answer is correct. Try to find third part in which you have to use n is equals to 3 in fourth equation of motion, and you will get your answer. Yusuf, just send me your answer.
Yes, sir.
Or just send me your answer. Part, you have to use first equation of motion as v is equals to u plus a times t. Now, if you put the value of u to be 0, a is just 1 and t is 5.
Sir, the time you 5 seconds.
Here it is given. You have to calculate for 5 seconds. Similarly, use S nth, which is equals to u plus a over 2 times 2n minus 1. Where n is the time interval we have given as 3, is just 1 and u is 0. Put all the values and you'll get the answer. On putting the value of u to be 0, a to be 1,
The 2 meter.
if you put the value of n to be 3 minus 1, so it would be 2 into 3, 6, minus 1, 5 over 2, that is 2.5 meter. Okay, Mohammed Amir?
So we could have cancelled 2 into, right?
Of board mass. Multiplication comes first or subtraction comes first?
No, we could have cancelled 2 and 2. The 2 in the denominator and the 2 in the multiplication.
Bracket comes first or multiplication comes first?
Bracket, okay.
So you have to use first bracket, okay?
Yeah, understood.
So is it clear to you all till this part?
Yes, sir, understood.
So just revise this whole part and try to solve more and more problems regarding this. In next class, I will define some of property and some more application of it. And then we'll start free fall, that is motion under gravity. Okay?
Okay, sir.
Okay then. Good night. Take care.
Thank you, sir. Have a good
Thank you,
night.
sir.
Thank you.